Do you remember the definition of continuous data? Do you know what is the continuous sort of a data?
Yes, 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 I
Okay,
remember.
great. Then please say it.
Yeah, you can go ahead. I will pick up.
Okay, Ratna, any example
Yeah,
of,
I
yeah,
was just thinking of that. So win or lose versus average run rate, maybe
average run rate? How would you
for
display
all the
average?
matches. For all the matches, if it is all the matches,
How would what would be the measure of unit for average run rate? Can you
it's
divide the average run rate? It would always be in decimals, no?
yeah.
So how would that be continuous?
But it can take any decimal value actually. So it can be 4.33 or you can go
Good.
deeper
So we
and
can
it
take
can be
number of
4.3267.
matches played.
Remember we talked about this thing in the discrete versus continuous also.
Yeah, yeah.
Continuous
The
is
average.
when the unit gets changed. Okay, from meter to centimeter to millimeter. Here, if you say run rate 44.444 or 44.45, my minute of unit of measurement remains the same. Okay, so win
But
versus loss.
we can also like the run rate. It can also be like she said per match or
Yeah,
you
for
know per over or
for one
per
tournament,
50 overs or something like that.
But can you
we cannot break
now?
it further.
Okay,
Yeah,
no, sorry, you are correct.
we
No
cannot
problem.
break it further. Yeah, I understood.
So Ratna, anything?
Uh,
Mahesh, Ratna,
Most of the examples.
continuous. A lot many examples.
High low prices versus percentage of sorry, price.
High versus low,
Low
and discrete and continuous would be
uh, price
price. And how do you measure? How do you display the data of price?
in INR rupees.
Great, very good, very
Yeah,
good.
that can be divided.
The
Time also.
price of the vegetable or whatever. Okay,
And the time
and could be the time also. So time. Okay,
and the
good.
temperature.
Anything, yeah, anything could be continuous. So this is what we have just discussed. Okay, so we have covered three scenarios out of it. Okay, and now we have a test called, which is called as GLM. This has many variants. So general linear model, there are many combinations in it. So uh, there will be lot many coming. I'll be asking many more questions, and everybody will get a chance to answer here. So, okay, so let's talk about general linear model. Okay, in general linear model, I have many variants. So let me discuss first of all the type of data. If my y is continuous and my x is discrete, okay, then I will call GL. So I have covered all the categories: y continuous, x continuous, y discrete, x discrete, y discrete, x continuous, and y continuous, x discrete. Can you think of any other combination between discrete and continuous versus x and y?
No.
Nobody can.
There can be if you know like for BLM there is a prerequisite. So what if Y is not binary?
Yes, y has to be binary. That's why it's BLR.
Okay, no, that's why it's a different variant. So Y is discrete, X is continuous, but
Yes.
Y is
Y.
not binary.
Yeah. So then there are other tests, which we majorly don't use. So which is OLR and NLR, which is ordinary logistic regression and nominal logistic regression. So where y has to be ordinal, y has to be nominal. Okay, so that's the only difference that it has. I can cover these tests also with you if we have time.
Simar, just a question here. In the correlation and regression, when you have y continuous and x continuous, we haven't mentioned anything in the prerequisites, but we discussed that in continuous data, our hypothesis test will change based on the data normality. So, will
There
it
is,
be?
there is, yeah. So Anand, there is no prerequisite in case of a correlation and regression. Whether it's normally distributed or not normally distributed, I would still go for a correlation and regression, provided my both variables are continuous in nature. Likewise, height versus nutrition, okay, handling time versus hold time, cycle time versus tenure, whatever that. But there is no prerequisite, Anand, whether it is normally distributed or not normally distributed.
So Simar, the reason we do a normality test is to determine whether we want to go with a mean or a median, but
Right.
it directly does not have any impact on our hypothesis testing, the tools that we will use here.
Yes, so that is going to come now. That is going to come in the general linear model that we'll be talking about.
Okay. Okay.
Yeah. Let me finish that, and
Sure.
then if in case we have a question, then I'll answer.
Sure.
Okay.
Thank you, Simar.
No problem. So y continuous and x discrete. There are lot many variants that I was talking about. Okay. Now, in this case, if the data is normally distributed, okay, here I will go for normality. So when my y is continuous and my x is discrete, if my data is normal, then I have three other variants. If I have to compare one subgroup, then I will do a test called one sample t. If I have two subgroups, then I'll do a test called two sample t. I'll explain all these, and I will do a mini tab hands-on and explain it to you as well. So just writing it down. And if I'm more than two subgroups, I will do a test called one-way ANOVA. Repeating, when my y is continuous and my x is discrete and my data is normally distributed. Okay, normal is very, very important here. If in case I have one subgroup, I will do a test called one sample t. If there are two subgroup, I will do a test called two sample t. If I have more than two subgroup, I will do a test called one-way ANOVA. Okay. Now, again, if I have y continuous, x discrete, I have not normal data. If I have one subgroup, I will do a test called one sample z. If I have two subgroup, I will do a test called man Whitney. If I have more than two subgroups, I will do a test called Moore's median. There is no other prerequisite as of now. Okay. So in case of y continuous x discrete, if there is normally distributed, then in that case I will do these three tests, and if it is not normally distributed, there are three more tests as well. I will also teach you tomorrow or maybe next week how to convert the not normal data into normal data as well. Okay, there is an option there in mini tab where you will be able to convert the not normal data into normal data. So in that case, you would have two options: either to go for not normal test, or either you can convert not normal to normal. So I'll cover that at the end. That's a little complex, but yes, these are the 6 different types of tests that we do when in case of y continuous and x discrete. So let's cover the one subgroup first, and then I will talk about the two subgroups later. The only difference between these two tests, two sample t and one-way ANOVA, and man-Whitney and Moore's median, is only in case of normal and not normal. Otherwise, it shows the same purpose. Okay, let's go one by one. It's seems getting a little complicated because these are the new tests that we've heard. Okay, one sample T. These tests, one sample T, one sample Z, are basically used for baselining. Do we know the meaning of baselining here? Anybody wants to know what is the meaning of baselining? I can explain. Or does anybody know the meaning of baselining? Can please talk about it? What do you mean by baselining?
Baselining is, setting a certain bare minimum requirement.
Yeah. Setting a bare minimum standard, bare minimum target that where I should be aiming at. So that is called baselining. So if I commence any project or if I commence any new process, I would definitely give a baselining, which is sort of a target or a standard that where I would be reaching at. Okay. So that is called baselining. So one sample T and one sample Z. These two tests are for baselining. Okay. So once we get into the mini tab, then I will talk about it. But when you have two subgroups, then in that case, you would go for two sample T. And in case of not normal, we go for manual. So now, friends, time to give examples. So Y continuous and X discrete, wherein X I have two variables. So can someone give me an example of Y continuous X discrete for two sample T? The same can be for Man Whitney also. So now,
Yeah.
please give any example of Y continuous and X discrete where it has two variables. Please try anything. Don't worry whether the answer is right or wrong. I just want everybody to make an attempt.
What do we mean by two variables?
Two variables means two subgroups. Likewise, we have binary, pass fail. Okay. And more than two subgroup is when you have more than two or three, more than two combinations.
Okay, so can we say like for two subgroups, we can say, let's say people of Karnataka versus people of Tamil Nadu.
Absolutely, absolutely, absolutely. Bang on. So, Vasu, would you like to give an example? I think Ashwini has already helped you in answering the X, but any example of Y continuous from your side?
Y continues with units
Units of?
of the population numbers.
So, what are we measuring? What is the opportunity statement here? Like, so you can give examples from your respective organizations. If you're into manufacturing, if you're into service, if you're into R&D, if you're into banking, finance, give examples of your own metric which you work daily, day in, day out. So any example of continuous data, any example of continuous
Data measurement.
measurement of?
Let's say turnaround time of base A versus base B.
Very good. So turnaround time versus base 1 versus base B. Base 2. So which means I want to check with the help of two sample T that whether there is any significant difference between base 1 and base 2. So I will do the mini tab and then we'll make you explain. But I want you to give more examples. Any more example? So now Rahul, any example of Y continuous and two subgroups? It's pretty okay. When I was
Like
at that time,
shaft diameter versus
sorry,
product A and B.
sorry Mahesh, can you repeat?
Shaft diameter, yeah, shaft diameter versus product A and B.
Very good. Diameter versus product A versus B. Very good. Rahul, any example from your side? Rahul, can you hear me? Am I audible? Rahul is facing some network issues. So, Bhanu,
Can it be machine versus weight?
you can say weight versus machine, but not machine versus weight.
Yeah. Weight versus machine.
Which? So weight versus
Machine.
it has to have two subgroups. So weight versus, you can say machine 1 and
Machine 2.
machine 2. Absolutely. Okay, great. Remy, any example of one-way ANOVA wherein you have Y continuous and X has more than 2 subgroups?
Do we have Rumi on the call?
I don't think we have limit.
Yeah, I think she hasn't joined yet.
So Simar, in this case, we can also have a scenario wherein we have sales figures in dollars, and then you have location 1 and location 2.
Absolutely.
Maybe
Yes.
2.
Yeah.
Yeah.
Absolutely correct. On and on. Piyush, we haven't got to hear from you yet. So any example of one-way ANOVA?